Welcome to Summarize Science. Today we're looking at a breakthrough in saving endangered languages using artificial intelligence. Linguists are racing against time to document languages like Wardaman, an indigenous Australian language with only 2 speakers left as of 2025. Normally, AI needs thousands of hours of data to learn a language, but researchers only had 6 hours of annotated audio for this project. They developed a system called WARDEN, which stands for Wardaman Decoding Engine, to handle this extreme challenge. WARDEN breaks the process into 2 distinct steps, transcription and then translation. First, the AI listens to the audio and turns it into phonetic text. Then, it uses that text to create an English translation by passing it through a large language model. To make the transcription better, the researchers looked for a proxy language that sounds similar to Wardaman. They discovered that Sundanese, a language from Indonesia, shares many of the same phonemes or sounds. By starting the AI with knowledge of Sundanese, they gave it a massive head start on understanding Wardaman's speech patterns. As seen in these charts, Sundanese has the smallest phoneme distance to Wardaman compared to other candidates like Uzbek or English. For the translation phase, they didn't just rely on the AI's general memory. Instead, they built a special lexicon matcher that acts like a high-speed digital dictionary. This matcher looks for words in the transcription and finds the most relevant entries from a Wardaman English dictionary compiled by experts. The example here shows how specific words like Miller are identified as a digging stick to guide the AI. This procedure gives word-level clues to the AI, which helps it avoid making wild guesses. The researchers also use data augmentation, creating variations of the transcription to help the model handle real-world audio errors. This transforms the AI from a simple translator into a knowledge-grounded interpreter. The results of this specific design are quite startling. In their tests, WARDEN outperformed massive, famous models like GPT-5 and Whisper for this specific language. This is impressive because those larger models were trained on millions of times more data than the 6 hours used here. The researchers found that their R's version of Whisper achieved a significantly lower error rate than standard versions. Looking at the translation scores, their system achieved a BLU score of 12.40, which is much higher than the standard LLM outputs. They also found that the lexicon feature was the single most important factor in getting a usable translation. Without that dictionary connection, the quality of the translation dropped by nearly half. This proves that human expert knowledge is still vital for teaching AI about rare and complex languages. To recap, the WARDEN system uses phonetic similarity and a smart dictionary to save a language with almost no digital footprint. They have proven that you do not always need big data if you have a smart design grounded in linguistics. This breakthrough could mean the difference between preserving a culture's voice or letting it be lost forever. In the future, this technology could be used to document hundreds of other endangered languages across the globe. It turns a manual process that used to take days of expert work into something that can be assisted by AI in seconds. Thanks for watching Summarize Science. Stay tuned to see how technology continues to protect our global heritage.